Hi, in this video I'm going to go through question 1 part H on the MAP 2010 paper. So in this question we're given this equation here where n is a positive integer and k is a real number, and we need to decide which of these four statements is true. Okay, so let's look at the first one. If n is 3, then the equation has no real solution for some k. Well, what's it going to look like if n is 3? Well, it's just going to be some cubic like this, right? And it's going to go down to minus infinity as x goes to minus infinity. It's going to go up to positive infinity as x goes to positive infinity. So wherever I choose to draw my k line, then I'm always going to be able to find some places where this line crosses my cubic. And so we know that the answer isn't A. Okay, now what about this second statement? If n is even, the equation always has a real solution for any k. Well, what's this going to look like when n is even? Well, a bit like this. So when x is going to minus infinity, y is going to go into infinity. Then it'll squiggle a bit in the middle, and then when x goes into infinity, it's going to go off to infinity again. And well, we see that there is a value of y that this graph doesn't go below. And so if we choose our k to be lower than this value of y, then we can see that it's going to miss our graph altogether, and so there won't be any real solutions. So answer B is also incorrect, it's false. Okay, so what about these last two statements? Well, for C, if k is greater than or equal to 0, well, our polynomial is either going to be odd, so it'll go off to minus infinity when x goes to minus infinity and infinity when x goes to infinity, with a bit of a squiggle in the middle. Or it's going to be even, so it will go off to positive infinity when x goes to minus infinity or infinity, with some squiggling in the middle. And you can see that both of these graphs take every value from 0 upwards, right? So we know that this has roots at 1, 2, 3, and so on. So we know that it's going to cross the axes, so it takes the value 0, and it also goes off to infinity when x goes to infinity. So this graph will take every value of y between 0 and infinity. And similarly for this graph, well, it also has roots, and so it takes the values 0, and it also goes off to infinity when x goes to infinity. So this graph also takes every value between 0 and infinity. So wherever I might choose to draw my k on these, then I'm always going to get some solutions. And so it seems that C is true. And just to double check, let's work out D as well. So D says the equation never has a repeated solution for any k and n. Well, if I just choose n is equal to 2, my quadratic, so the left-hand side is just going to be x minus 1, x minus 2, so it'll look like this. And if I chose k so that it touches this minimum point here, well, this point here is going to be a repeated solution, and so we see that D is false too. So our answer is indeed C.